Dear friends, next topic after weight corrosion or mechanism of weight corrosion is, after that it is the factors affecting corrosion. Okay. Now as far as exam is concerned, you may get one question of 6 marks, maybe like explain 6 factors affecting corrosion. Meaning is that you are getting 1 mark for one factor. In that case, just minimum content is required. Whether that factor, one second. Okay. For 1 mark, how the factor changes the rate of corrosion. Whether the rate of reaction increases or decreases. And maximum one example. This much is sufficient. But there are certain factors. Very rarely they are asked for 2 marks or even 3 marks. In that case, we need to elaborate by giving examples, by giving reactions, by giving different situations and some minimum explanation. Okay, let us go to that part. Factors affecting corrosion. These are the factors who are either increasing or decreasing the rate of the corrosion reaction. Okay, this can be categorized, this can be grouped under 2 main headings. First type of corrosion, first type say it is based on nature of metal. Under this heading, nature of metal, will explain certain factors. So first point, nature of metal. How this nature will affect the process of corrosion. Okay, this point looks theoretical, isn't it? These are topics which looks theoretical, but don't make it a theory type answer. Don't write paragraphs. Write minimum content, example, diagrams, hypothetical structure, reactions, etc. First part is under this heading. First factor is position of metal. Position of metal in the electrochemical series or galvanic series. Okay, how the position affect the rate of metal? 1 mark answer is when the metal who are placed at the place high up in the series will work as anode, metal placed at the bottom of the series will work as cathode, or top elements above hydrogen having negative value of electrode potential will prefer to work as anode part of cell, undergo oxidation. If they are below hydrogen, SHE, their values of electrode potential is positive, they will work as cathode part of the cell. So that is one point, right? So simply high up negative, anodic, below hydrogen, positive, cathodic. If you want to elaborate answer, let us give some points. For example, one point is over. Second, suppose magnesium strip of this size is in electrical contact with zinc. This electrical contact, say. Okay, and it is exposed to this medium. This is a medium. This is a medium, right? And in a second cell, the same size of magnesium strip is in contact with Fe strip of the same size, and they are in electrical contact and they are exposed to same medium. Okay, this is also this rate of first type of cell and rate of second type of cell, means corrosion tendency of metals in the first type and second type depends on where they are placed in the series. Okay, now I know the series, you know the series, we know that all these 3 metals are having negative value of standard electrode potential. So meaning must be they prefer to work as anode part of the cell. But when 2 negative combine, more negative will work as anode. This will be anode. Okay, the less negative will work as cathode. This will be anode. This will work as cathode. More negative anodic, less negative cathodic. Here also, if we want to give the position in the series, suppose this is the first element, this is the 5th element. Okay, from top to bottom, this is the first element, this is 8th element, right? In this case, rate of reaction, corrosion of this magnesium rod will be magnesium strip or this metal will be faster compared to this. First element, fifth. They are comparatively close to each other. First element, eighth element. More is a difference in the electrode potential value. One will be strongly anodic. One will be strongly cathodic. Okay. So in the second type of cell, rusting of magnesium will be faster. This is your explanation. Third is what? Third example. What information we get from the position? We also know that all the elements who are placed above hydrogen in the electrochemical series are having negative value of electrode potential. They undergo dissolution. We have seen the case, zinc rod exposed to acidic medium, acidic solution, it undergo dissolution, but it will be observed by evolution of hydrogen gas. So all the elements who are placed above SHE in the electrochemical series having some negative value of electrode potential will undergo dissolution with the liberation of hydrogen. That is also information we are getting from the position of element. Right? Suppose I am zinc and you 50 guys are hydrogen. So my potential is more negative. I have got more potential than yours. So I can remove you from the class for any reason. Right? My potential, I can displace you from the class. But during that process, there is energy loss. So there will be this zinc will form zinc cations. I have to lose energy. I will undergo oxidation. My dissolution will be there. It is accompanied by evolution of hydrogen. Those who are placed below hydrogen having positive value of electrode potential, they are inert, they are noble. This medium, acidic medium, will not be affecting on this element. That information also we get from the position of electrochemical series. Apart from that, we also know that there are certain elements, there are certain metals. What are the names? Aluminium, okay, then titanium, titanium, then chromium, then cobalt, nickel. These are the 5 elements. Their position is high up in the series. They have got negative value of electrode potential. They should undergo corrosion at a rapid rate. But in the medium, they resist corrosion to very high extent. That is because they shows active passive behavior. They shows active passive behavior. This information also we are getting from the position of the element from the series. This is the answer of 4 marks question. First is positive negative anode cathode. Second, first element coupled with the fifth, first element coupled with the eighth element, change in the corrosion of the cell reaction based on position. Those who are placed above hydrogen, below hydrogen, reaction rate in acidic medium is different based on the position, and this is also based on the position. So if a question is there for 4 marks, I think that much answer is required. But all the factors may not be asked for 4 marks. There are hardly few factors. Like this is one factor, maybe for 3 marks. So 3-4 points. Some reaction like acidic reaction, we can write the acidic reaction. Zinc exposed to acidic medium. This is the reaction. Electrons will be taken by H plus ions. Okay, and there is a liberation. Next reaction is zinc. These electrons get cancelled. Zinc exposed to acidic medium undergoes dissolution, forming ions accompanied by evolution of hydrogen. In no time we can write the reaction. That required good writing practice. That required understanding to some extent. It will serve the purpose. So this is the one simple factor, that is position of metal in the electrochemical series or galvanic series. What is the second factor? Second factor is relative area of anode and cathode. Relative area taken by anode and cathode. Actually, these factors are not only factors. This is not only for explaining and giving example. These are your designing principles. As a engineers, these are your designing principles. How come? If I'm a designer, if I'm designing some machinery or some apparatus, some equipment, I know that if I am coupling element number 1 with the 5th, rate of corrosion is less. So at the same time, if I am coupling element number 1 with a 10th, rate of reaction is found to be very high. So I will prefer this system. I will try to join two elements which are close to each other in the electrochemical series. So this kind of information, these are actually our designing principle. One by one we'll try to cover up. Okay. Second is relative area of anode and cathode. Right. Suppose in my system, in my machine part, I require to join two different elements. Yeah, same element, two different elements, and area occupied by two elements is found to be different. This is that factor. What is that? Suppose this is the area taken by anode. Anode has given this much area, okay, and cathode has occupied this much area. Okay, area of anode is higher than cathode, and it is required to have electrical contact, and they are exposed to so and so situation. Okay, in my designing, I have given some area to anode that is higher and some area to cathode that is comparatively less. And in second system, area taken by anode is same like the first system. That this is my first system, and area taken by cathode is found to be very high. This is cathode area. So this is one part of my machine. This is another part, and they are in electrical contact and they are exposed to same medium. This is my medium. Medium is supposed found to be same. It is same medium. Then which system I should follow? That part. Then which designing should be adapted, should be accepted in my machine. It is coming this factor. What will happen if this is the case, or what will happen under this case? This system is preferred. Preferred system is first system. Why? If area of cathode is more, if larger area is given to cathode, then what will happen? We know that at cathode part there is a reduction reaction, there is a gain of electron, and cathode part get protected by gaining electron. But who is providing electron? Anode is providing electron. Anode is undergoing oxidation, forming metal ions with a loss of electron. So if area occupied by cathode is very high, then its demand of electron will be very high. And to fulfill this high demand of high cathode, then anode has to undergo oxidation at a very rapid rate. So there will be dissolution of this anode at a faster rate. So to avoid that, in any system, in any structure, area of cathode should be as small as area of cathode should be small compared to anode. Okay, so it is directly proportional. Area of cathode increases, rate of anode dissolution also increases. So in my system, I will follow this principle. Area of cathode should be as bigger as possible compared to cathode. So this is the second factor. This should be avoided. Area of cathode should be smaller than area given to anode. What type of questions they will ask? What will happen when copper sheets are joined by iron nails? Question will be, this is Fe, these are the nails, and we have joined this with copper sheets. These are again iron nails, and so on. This is copper sheets. What will happen in this case? This should be avoided. We know that this is having Fe having negative value of electrode potential, so this will work as anode. Copper having positive, so this will work as cathode, and in this medium there is a formation of electrochemical cell. But here area taken by cathode is very high, who require electrons, who undergo reduction, and this demand of electron is fulfilled by this Fe anode. And to fulfill this high demand, it has to undergo oxidation at a faster rate. It will undergo dissolution at a faster rate. So this should be avoided. What will happen? There will be dissolution of Fe. The same reaction we can write what we wrote for mechanism of corrosion, weight corrosion by absorption of oxygen, isn't it? So this is one simple factor. This way you have to elaborate. This way you have to, by giving, instead of writing theory 4, 5 lines, 10 lines, you show the rough structure and in 2, 3 lines you can answer it. Or you can give this kind of simple hypothetical examples. This is what is expected in the examination. Then third part is impurities present in the metal. Impurities in the metal. Impurities present. Impurity present in the metal. Now this impurity is of two types. This impurity if it is forming a homogeneous system, metal and impurity forming homogeneous system, then it will not cause corrosion or it will suppress the rate of corrosion. At the same time, if this impurity is forming heterogeneous system, then rate of corrosion of anode or metal rapidly increases. So how to explain this? This impurity may form homogeneous system. It may form homogeneous system. Examples are alloys. Alloy shows high resistance to corrosion. That is one purpose of making alloy is corrosion resistance. But alloy is impurity in the crystal, impurity in the metal. It is impurity in the metal. But if the impurity is forming heterogeneous system, then there is a rapid rate of corrosion. Give the example, one example of homogeneous system. Take case of brass. Brass is alloy of what? Copper and zinc, right? Okay. Original crystal is copper. Particles may be like this. This is the original crystal of copper, right? And this brass is an example of substitutional alloy. There is substitution of this copper by zinc. Few of the zinc are replaced by copper, like this. And there may be 50% copper, 50% zinc, one alloy. There may be 40, 60, 70, 30 and so on. But this impurity is homogeneous. This is not causing any harm to the system. In the same manner, we can give the example of steel. What is steel? Steel is alloy of carbon and Fe. Rather, it is Fe and carbon. Main element is Fe, iron. This is an example of interstitial solid under heading crystal defects. So there are defects in the Fe. Fe is what? 26, like this. This much volume is required. Okay? And during making of the steel, this carbon is added from outside as an impurity. And that small carbon, number 6, small volume is required, that fitted in the voids, that fitted in the gaps properly. That is there to harden the steel. Hardness is because of carbon. So this is impurity actually, carbon in Fe. But this is forming homogeneous system. So that resists corrosion. So homogeneous system is formed. Example alloys. Atomic number of copper is 29. Zinc is 30. Almost same volume is required for both. So substitution is possible. Taking out this and keeping this there. So this is case. At the same time, if heterogeneous system is formed, what is that? This is a pipeline. Steel pipeline, Fe pipeline, having some copper as an impurity, is carrying some water or some solvent. This is Fe. Then if copper is there as a solid impurity in the undergone pipeline, out here it is, this copper is here, and that result in the formation of electrochemical cell in between Fe and copper. Fe is strongly negative, copper is positive, they will form electrochemical cell and rapid rate of corrosion is observed. In the same manner, these are the iron bars fixed in the window, right? Some dust particles are there, some sand particles are there, some oil globules are there, some water particles are there. Okay? And that also result in the formation of heterogeneous system. Okay? So medium will attack on this part. On this underlying part, medium may not be directly attacked. So then on this part, medium is different, direct attack. On this part, direct attack may not be there. On this part, direct attack may not be there. So they will behave differently. They will result in the formation of anode and cathode that we have seen in the earlier mechanism. So rapid rate of corrosion is observed. Okay. Impurity on the metal. These are the cases. Impurity in the metal. These are the cases. Okay. In your textbook, reference book, they have given like zinc will be 100% pure. Rate of corrosion is almost 0. When that impurity is going from 100 to 99.95, it is increasing the rate of corrosion by 2500 times. So very rapid rate of corrosion observed when impurity is present on the metal, which result in the formation of heterogeneous system. So these are the cases. Okay. Fourth point is physical state of metal. Fourth factor is physical state of metal. Physical state. What is physical state? Let us take case of first A group element, second A group element. Their grain structure, their size is found to be very small. Okay, so they require very minimum amount of energy to undergo oxidation. At a even room temperature, they show oxidation reaction. That is dissolution reaction. So physical state, smaller grain size, mainly first A group element, alkali metals, Secondary group elements, alkaline earth metals like lithium, sodium, magnesium, calcium, beryllium, strontium, and so on, they rapidly shows their corrosion rate is found to be higher. At the same time, transition elements, larger grain size, quite higher amount of energy required, higher temperature required for undergoing oxidation for the metal. So their corrosion at a normal temperature is found to be very minimum. Or simply, this is my pipeline. This pipeline underground the soil, carrying some solvent or some liquid or some gas. Internal structure is found to be intact. Maybe like this. Intact structure is there. When you are going for roughly building of the pipeline, bending is there. Maybe roughly one example. So this internal structure remains intact. This much part remain intact. Some stress is observed on this part, bended part. So this shows weakening of the metal. This internal structure get disturbed, that will work as anode. Rest intact part will work as cathode. And in the medium, there is electrochemical corrosion. It may be stress, it may be welding of the pipelines, it may be coupling of the pipelines, and so on. It may be the joints joining the two pipes, internal structure get disturbed, physical state changes, will work as a anode part. Okay. Even say copper, orientation of crystals on the different faces of copper is found to be different. They behave differently. Like I am on one face with my front view. Medium or the enemy directly cannot attack on me. I can oppose the attack from the front side, but enemy, the medium, can attack from my back side. Structure is different, isn't it? So if you take the arrangement of copper, crystals of copper in the different faces is found to be different. So accordingly, it shows the corrosion tendency. This is a factor called as physical set of metal. You can give this example. Stress on the metal, coupling of the pipes, bending pipes, welded pipes, joining of the pipes, structure get changes. Or in the different phases of crystal, internal structure is found to be different, corrosion tendency is found to be different. This way you have to elaborate. Okay. And fifth point is nature of oxide layer. Under heading nature of metal, it is nature of oxide layer. Nature of oxide layer, right? What is nature of oxide layer? We have already seen in a dry corrosion, this oxide layer is of as per peeling Bedworth rule. Nature of oxide layer is it is stable and protective. Second, it is porous and non-protective. Third is it is unstable oxide layer, and fourth is the volatile oxide layer. So in a dry corrosion, as per peeling Bedworth rule, the oxide layer is of four types: stable and protective. Okay, in such cases, corrosion rate is initial rate is there, but after once you form a uniform coating on the exposed part, further rate of corrosion decreases to high extent. In case of porous and non-protective, if this is my metal, this is a exposed part, on this some coating is formed, the layer is not protective, some gaps are there, some cavities are there. Through these cavities, media will attack and continuously corrosion reaction occur. In case of unstable oxide layer, like silver, like gold, like platinum, like palladium, even copper, they are noble element. The dry medium may not attack on them. There is no such corrosion is observed when oxide layer is found to be unstable. And in case of volatile, we have given example of molybdenum. It will form molybdenum oxide. That is very rapid rate of corrosion. The coating get formed by consumption of metal and it vaporizes. It is volatile, and again underlying fresh part is ready for further corrosion. So very rapid rate of corrosion is observed. So separate 4 mass question may be asked. In that 4 mass, 4 types, their meaning, their few example, and at least one reaction. Like this table, aluminum form Al2O3, or and few examples they are already given in my notes that you have to write. For 1 mark, just write 4 types, that is sufficient. And one line is nature of oxide layer will decide the course of corrosion. Here very minimum corrosion, continuous corrosion, no corrosion, very fast corrosion. I think that much is sufficient. So this is a one more factor, that is a fifth factor. Then it is physical state, nature of oxide layer, fine, and passivity of metal. Already we have explained this. Passivity of metal. Passivity of metal. What is passivity of metal? Again I repeat, just now mentioned aluminium, titanium, chromium, nickel, cobalt. These are the 4-5 elements. If you look at their position in the electrochemical series, if you look at their place in the series, electrochemical series or galvanic series, you will find their electrode potential values are negative. Means they should work as a anode part and should undergo corrosion as per their standard electrode potential value. But in actual practice, this element resists corrosion to very high extent. That still has chromium. Stainless steel utensils are not undergoing corrosion. It is mainly because of some minor amount of chromium. That shows very high resistance to corrosion. But when steel articles, when you go for welding of the steel rods, steel articles, we are using some oxyacetylene flame. That chromium will form chromium carbide. Then there is a depletion in the chromium composition. In that case, steel corrodes. Now, why they resist corrosion? As per their position, they are anodic, but in practice, they are non-anodic. They shows active passive behavior. These elements shows active passive behavior. Why this happens? Say when you take aluminium, or when you take nickel, or when you take cobalt, they shows initial rate will be there. They shows corrosion tendency as per their negative value of electrode potential, as per the series to some extent. And on the exposed part, they form a fine layer, very thin, invisible layer, very protective and stable layer, which is of self-healing nature. Even if it gets broken down, it repairs itself. Okay, like tubeless tires. I repeat, these elements initially to some small extent, they shows oxidation reaction, undergo corrosion. That's why their values are negative. That's why they're anodic. But after that, once they form a layer on the exposed part, that layer is found to be very stable, very protective, very fine layer, invisible layer, and it is of self-healing nature. Further corrosion rate will decrease to very high extent. That's why they are called as, they are active, but in practice they are passive. They will not undergo corrosion. They resist corrosion to very high extent. So this is the passivity of metal, isn't it? This is the passivity of metal. Few elements shows passivity, right? And one more factor is, it is solubility of corrosion product. Based on the nature of metal, it is solubility of corrosion product. Solubility of corrosion product. There are some products formed on the exposed part of metal by the medium who are found to be soluble. Like example, metal exposed to halides, it will form metal halide. This product is found to be soluble. This product is found to be soluble. And if it is soluble, again underlying part of metal exposed to medium, corrosion continuously takes place. In case of lead, Pb exposed to acid, H2SO4, that is forming PbSO4. PbSO4 as a sort of coating on the exposed part of Pb, lead. That coating is found to be insoluble. That coating is found to be insoluble. That is not going to dissolve in the medium. So it will suppress further course of corrosion. Okay. In case of Fe exposed to H2S in a petroleum industry, it will form FeS layer. This is also insoluble to some extent, not 100%. Partially it is insoluble, but partially insoluble means coating get removed and continuously underlying part get corroded, isn't it? And eighth factor is over voltage. It is over voltage, or it is called as over potential. over voltage or over potential. That I will explain in my next video. Okay, that I am just taking. So these are the 8 factors coming under heading nature of metal. I hope you have understood. Okay, thank you.